Okay, cool. Now, I'm not actually going to take the time to redraw the whole thing. I'm just here, hopefully this is more of just an answer check for you. Numbers 1 through 6 are going with that top function. And this one's asking about what is the limit as x is approaching 1? So, whenever I look at my graph, the limit as x is approaching 1, that's a pretty smooth situation. And doing the best I can, it looks like it's around 1, okay? If you did a decimal or fraction close to that, that's just fine. Number 2, it wants to know the limit as x approaches 2 from the right. So from the right, if I look at my picture, it really looks like it's approaching 3. It might be a little bit more than 3, but 3 looks pretty close, maybe 3.5. And then number 3, it says, what is the limit as x approaches 2 from the left? And from the left, that is definitely a higher place. It looks like that's happening at 4. Now number 4, what is the limit as x approaches 2? That is the overall limit. Now these two were not the same, which means this does not exist. And number 5, what is f of 2? So f of 2 would be where the point actually exists. And the point exists at the filled in circle, the solid circle, which was happening at 4. And then number 6 is, are there any discontinuities? Well, this is a huge discontinuity, this whole situation right here. So there is a jump discontinuity at x equals 2. And where else might there be a discontinuity? I think that's the only other one. The end of the graph, those are not marked with anything, but I'm going to assume there were arrows on the end of the graph. Wherever you see those, I'm assuming those are going to keep going. So that'll be my only discontinuity. Okay. Yay, isn't this fun? Okay, moving on to the next one, 7 to 12. On number 7, what is the limit as x approaches 0? Well, if you look at x approaches 0, it's a nice smooth curve, and it looks like it's hitting at the origin. Number 8, once again, we're approaching 2 from the, what is that, plus sign, from the right. So from the right, it looks like that's approaching at 3. And then from the left, it looks like it's approaching at 4. So it looks a lot like the one above it, just kind of a zoomed in picture. Number 10, it wants to know about the limit at -1. Well, notice there's no plus or minus by that -1, so it wants the overall limit. Now I'm going to put does not exist because the limit from the right does not equal the limit from the left. So if you're ever asked to give some kind of proof, sorry, let me slide my f of x in there. If you're ever asked to give proof, you can always do that. Those two are not the same, so I know the limit doesn't exist. Now, does f of -1 exist? Is there a filled in circle at -1? Yes, there is. It looks like it's happening at 1. So that would be my answer there. And number 12, are there discontinuities? Well, this graph has a couple of discontinuities. At -1, there's a jump discontinuity at x equals -1. And you know what? That's the same kind of discontinuity at 2. It's definitely a jump, okay? All right, now 13, 14, and 15, guys. These are going to be, answers will vary. Don't change your answer based on what I do, but I can check yours at tutoring to see if you did it correctly, okay? Create a graph that has a limit at 2, but is not continuous there. So a limit when x is 2. So what that means is for there to be a limit, I need it to approach from both the left and the right. So I'm just going to draw kind of a random, there we go. We're approaching a number from the left and the right, but it says it can't be continuous there. Well, the only way to make that happen, is to not do that. Okay, the only way to make that happen is to make that a hole there. Because if there's a hole, we don't exist, but we're still approaching from left and right. So I would have done something like that. Number 14, create a graph such that f of 1 is 3. So let me go ahead and plot the point 1, 3. Okay. but the limit as x approaches 1 is actually 5. So how could the limit be 5 if there's a point right here? Well, it's going to be like that one situation I told you where, there we go, where maybe the graph's trying to get to 5 from both sides, but there's a removable discontinuity and that's been put at another point, okay? So these are tricky and you may have come up with something else. Like I said, I'll check them when I see you. Create a graph such that the limit as x approaches 2 from the right is 4. 1, 2, 3, 4. So when we're coming to 2 from the right side, we have a 4. We're trying to get to 4. But the limit as x approaches 2 from the left is -2. So from this side, we want it to be -2. Now, it looks something like this. It'll be one of the jumps, you know. But what you want to do is right here, this is the critical part. They can't both be solid circles. They can both be open circles, or you can do one of each. Just do whatever you want, okay? It didn't say where it was defined or where it existed, so do whatever you want. 2 opens or one of each, but do not do 2 closed, because then it is no longer a function. It breaks the vertical line test. Okay, yay, I hope that went well for you, and we will expand on that in tutorials.